Hey guys, here's the basal ganglia video as promised. So the first thing I want to do is just go over a few images, some definitions and stuff like that, and then we'll get into the actual pathway, and then we'll talk about a couple of pathologies. So first thing I want to do is just bring up these terms over here. So these were used on our exam, so I just want to bring it up because I know that normally we just refer to them as the single structures, right? So the caudate, the putamen, the globus pallidus, which we have two parts to it, right? Interna and externa. So just be familiar with striatum and lentiform. I know we all probably have our own ways of memorizing the combination, right? So striatum is going to be caudate plus putamen, and lentiform is globus pallidus plus putamen. Yeah, so I just remember it that globus pallidus has that L in it, which is going to go with lentiform, and putamen is in both categories. So I just want to bring that up. So I also want you guys to get familiar with MRIs that have these structures. So you've been seeing these structures, but now you're going to be expected to identify them on your exam, right? So I know this isn't the best quality of MRI, but we have this orange part right here next to our lateral ventricles. That's going to be our caudate. So I'm just going to point out some other structures here, right? So we have our thalami here. We're going to have our internal capsule running like this, right? And then just outside, just lateral to our internal capsule, we have our putamen, right? So something to note is the internal capsule separates your putamen and your caudate, which we know that collectively are called the striatum. So the striatum is separated by the internal capsule. Keep that in mind. Also to note, the lentiform, the caudate has a very intimate relationship with the lateral ventricles, so keep that in mind. With complications such as hydrocephalus can push on this. And the other thing I want to say is we know that I know this might be jumping ahead, but I just want to push it, like show you guys on the image. The striatum is what degenerates in Huntington's, right? We know that it's the D2R receptor containing parts of the striatum, so that's going to be the caudate nucleus. So if you want to get as specific as possible, degeneration of the caudate is what causes Huntington's, which causes your boxcar ventricles. So I just wanted to bring that up since we have an image right here. You could see very enlarged lateral ventricles. So this is what's in our notes, right, our essentials. So this is an image that could possibly show up on the exam. It contains everything that we're going to talk about with basal ganglia, right? So we have our caudate sitting just under our lateral ventricles, internal capsule separating putamen, then putamen plus globus pallidus, we know collectively is called the lentiform nucleus, right? Then we have our interna and externa, and we know that they're each individually, respectively, involved in the direct and indirect pathway. And then we have our subthalamic nucleus, which is involved in the indirect pathway. So just note that these are all, because we have our thalamus right here, right? So these are just nuclei within our thalamus. The thalami sit in between that's our third ventricle right there. So just keep in mind these structures are all very, very close to each other. So that's going to be important when we talk about pathologies. I like this image because it's nice, simple, clear. If this one was a bit busy for you, then you can just keep this one in mind. Caudate, putamen, globus pallidus. So I just like that image, thought you might. So we have our midbrain here, right? And I wanted to give you guys this image just to talk about Parkinson's, right? Because we know that dopamine is our main controller, right, of our basal ganglia, and we'll talk about that in a little bit. So we know that here we have our cerebral aqueduct surrounded by our periaqueductal gray, and such and so forth, medial lemniscus, all that good stuff. And then we have our corticospinal tract, right? So we call these our crucerebri, right? Crucerebri on each side. And just by the crucerebri, we have our substantia nigra, right? And I just want to keep something in mind that there's two parts of the substantia nigra. We have the pars compacta, which is a little bit more, I guess, medial, we would call it, more internal, and then our pars reticularis, right, which is a bit more external. So those are two parts, and what controls our pathway is going to be the substantia nigra pars compacta. So this is from our notes explicitly, right, which is the more internal structure. So substantia nigra pars compacta, because they can put substantia nigra pars reticulata on the exam, and that would be a wrong answer, right, because the main supplier is the pars compacta. So keep that in mind.